Today in this lesson we're going to have a look at listing the sample space and determine the probabilities for multi-stage experiments using arrays or tables and tree diagrams. Now we're going to look at two different types of tree diagrams. One tree diagram is going to be simply where we have equally likely outcomes, and we're just going to have branches coming off. That might be heads, tails, head, tail, etc. And the other one is going to be what's called a probability tree. Now, in a probability tree, we might say that it's a bag, and in the bag it's got 9 green and it's got 5 red counters. So the probability of pulling out a green one is going to be 9 out of 14. The probability of pulling out a red one would be 5 on 14. And what we do is we put the probability on the trees, on the branches of the tree. So we're going to have a look at that second. But the first thing we're going to look at is a table. Now, we've done them before. A table can be used to list all the possible outcomes for a multi-stage event, a multi-stage event being one trial and then another trial, or one experiment and then another experiment. The outcomes for the first event are listed in the row headers, and the outcomes for the second event are listed in the column headers. Each cell in the table is an outcome. So at first, if we're tossing a coin, first toss, put them in the rows, and then your second toss, put them in the columns. Now, the reason I suggest you do this is because it is normal practice for us to, when we are looking at what's in a cell, to list the row and then the column. If you put them the other way around, if you put your first one up here, then when you list it, you're going to have to put the column before the row to list them in order. And that is not the way that we normally read tables, spreadsheets, etc. So I very, very strongly recommend that when you put them in, you put the first one in the rows and then put the second one in the columns. Okay, so if we're having a look at, for instance, this first example, listing the sample space for tossing 2 coins, toss 1, head or tail, toss 2, head or tail. So what we can have when we combine them together, we can have a head in our first and a head in our second, or we can have a head in our first going across the row and a tail on our second one. We can have a tail in our first toss and a head in our second toss, or we can have a tail in the first and the second toss. So we pull the sample space out of there. The sample space is in this square. There are the 4 items in our sample space. If we list them separately, our sample in our brackets, our braces, the sample space is over there. Let's have a look at our first example. We've got a shop selling jeans in 3 colours, blue, grey and white. So let's put them in our rows, blue, green and white, with either front or side pockets. Put them in our columns, front pockets, side pockets. There are equal numbers of each combination. Use a table to list the sample space. Okay, so there's our sample space. We've got our table, there's our sample space in there. There it is, and that's fair enough to leave in there. It's asked us to use a table for our sample space. Our sample space is, if we pull them out, B, F, B, S, G, F, G, S, W, F, and W, S. It hasn't asked us to list it in braces, it's asked us to list it in a table, so that's fine. Find the probability the pair of genes chosen at random will be. Now the first thing is we have got 6 possibilities, so all of our chances are going to be out of over 6. We're going to have a 6 on the bottom for all of these. Find the probability a pair of genes chosen at random will be blue with front pockets, BF. So there's only one BF combination in those. That was tricky, however that worked. So there's going to be 1 on 6 is going to be our answer. Grey with side pockets. Once again, GS, there's only 1. Our probability is going to be 1 on 6. Now be white. We're looking at white. That's all of this row. So there's 2 white ones. We've got front pockets or we've got side pockets. Our chances are 2 on 6 or 1 on 3. Have side pockets, the same scenario. Side pockets now, there's 3 of them with side pockets. And so I've got this completely wrong. It should have been 3 on 6, which is 1 on 2. And what you'll find is when you look at your notes, they will magically have reappeared or been corrected because I have picked up I made a mistake when I was putting them together, and I will put them back in. Okay, so there are our answers there. That should have been 3 on 6, which is a half. Okay, let's have a look at example 2. 2 red cards, R1, R2, and 1 black card, B1, are placed in a box. 2 cards are selected at random with replacement. That means we put them back in the box. So we can pull them out twice. We can pull out the red one first and the red one second. All right, so first draw, let's put them in our rows. Second draw, let's put them in the columns. First draw, we can have red 1, red 2, or black 1. And same with our second draw. Our sample space is listed in that table. Okay, so I haven't written it down there, that's not very clever. So it's asked me, the question obviously asks me the probability of getting a red, 2 reds. And so what I've done is I've listed that as probability red 1, R1, R2, or probability R2, R1, because that's 2 reds. So there's 2 of them. There's 2 possibilities. Yeah, my goodness, I am doing so badly here. Again, I'm going to correct this. There are 4 possibilities of getting a red, 2 reds. So our probability was 4 out of 9. Tree diagrams. Right, so that's using a table. So using a table, we construct the sample space and we can put our answers, work out what our sample space is, and then answer our questions. Tree diagrams. Now, so a tree diagram shows each event as a branch of a tree. They are used to depict the outcomes of multi-stage experiments. Let's have a look at our example 3. So these examples are the examples in your handout in your booklet. So a coin is tossed and a die is rolled. Construct a tree diagram. So first we've got our coin being tossed. I should have lines like that as well. So first we've had our we've got our coin tossed, head, tail. Second, we're rolling a dice where we've got a possibility of rolling a 1 to a 6. So we construct our tree as per first branch, HT, and then for each of the heads, we've got 6 branches going to our numbers. We list our sample space, H1, 2, 3, 4, 5, 6, and T1, 2, 3, 4, 5, 6. What is the probability of a head and a 1? So the total number we've got here is 12. All of our outcomes are out of 12. The probability of a head and a 1, there's only one outcome there. So our probability is 1 in 12. All right, then we look at example 4, which is in your booklets. I'd have to get it to see what the actual example is, but you'll be able to follow it. A bag contains 1 red and 1 blue marble, and another bag contains a red, a blue, and a green marble. 1 marble is drawn from each bag. Find the probability of getting 2 red marbles. So bag 1's got a red and a blue. Bag 2's got red, blue, and green. So my tree diagram, first choice, red or blue. Second choice, either red, blue, or green. My sample space is listed here. I've got 6 possibilities in my sample space. All of my questions are going to be that. Find the probability of getting 2 red marbles. So I'm looking for RR, and it looks like for once I've managed to do this correctly. There's only 1 possibility. 1 out of 6 is my probability of getting 2 red marbles. Example 5. A bag contains 2 red and 1 blue marble, and another bag contains 2 red, 1 blue, and 1 green marble. 1 marble is drawn from each bag. What is the probability of drawing 2 red marbles? My first bag has got red, 2 reds and a blue, so I've labelled them red 1, red 2, blue. My second one's got 2 reds, a blue and a green. I've labelled them red 1, red 2, blue, green. My sample space is over here, which I get from just going through my lines, through my branches and listing. I've got in total 12 chances, so they're all going to be out of 12. And that's asked me for 2 red. So I've got 2 red there, and I've got 2 red here. So I've got 4 out of 12. My probability is 4 out of 12, which will simplify to 1 on 3. Again, of all these things, if you put that into your calculator as a fraction, most of you got that A, B, C one, whatever that button looks like, and then you push equal, it will go from 4 on 12 to 1 on 3 for you. So if you're simplifying fractions or looking to simplify fractions, you don't need to use your head, you can use a calculator. Okay, so there are our, we're looking at our trees and looking at our tables, and all of those are equally likely when we put them in. Let's have a look at probability trees now. Now, probability trees are used to show outcomes which are not or equally likely to occur. The probability of each outcome is added to the branch, and the branch probabilities are multiplied together to give the probability of a particular event or outcome. So looking at example 6, we've got a bag containing 5 purple and 4 green marbles. A second bag contains 3 purple and 5 green marbles. So this first bag has got 9 marbles in it, and our second bag has got 8 marbles in it. If a marble selects from each bag, what is the probability of selecting 2 purple marbles? So our first bag has got 5 purple marbles, 9 in total. The chances of getting one is 5 on 9. The chances of pulling out a green is 4 on 9. So we've got them on our branches. Our second bag has got 8 marbles, and it's got 3 purples. So the chance of getting a purple, 3 on 8. Getting our green, 5 on 8. So we've added them to the branches, the applicant branches. Now, if we're looking for our probability of getting 2 purple, we're getting 2 purple, is it coming up this path here, our purple. We're multiplying those 2 probabilities together. 5 on 9 times 3 on 8 is 15 on 72. Again, if you throw that in your calculator and push equal to simplify, you for your 5 on 72. So I've pulled that out and done that there separately down here. Our answer, our probability is 5 on 24, gotten by following our branch and then looking at that and multiplying our 2 probabilities together on those branches. Another example, the probability that a chicken will survive the first 6 weeks after hatching is 0.7. Find the probability of 2 chickens hatched, both will survive. The first one will survive, but the second will die, both will die. Now in this case, what we're doing is we've got chicken 1 and chicken 2. Now chicken 1 can either survive or he can die. So that is what our 2 choices are, or our 2 outcomes are for chicken 1. He's got a 0.7 chance of surviving, a 0.3 chance of dying. Chicken 2's got the same scenario. So we're doing our branches off each outcome for chicken 1. He's got a 0.7 chance of surviving and a 0.3 chance of dying. And the same for if the first chicken died, the second chicken would have a 0.7 chance of surviving and a 0.3 chance of dying. So if we're looking in the first place for PSS, PSS will go up through here, and that is going to be, when we multiply those together, 0.7 times 0.7, which is 0.49. Well, down here, if I write them out separately, probability of the first chicken surviving, the second one dying. Now we're going surviving up here, and then we're coming through here for dying. We're into this one here. 0.7 times 0.3 equals 0.21. I've again pulled it off down here at the bottom where you can see that. Now the last one is asking us for both the poor chickens dying. So we come down for dying, we keep going for dying, we end up down here. 0.3 times 0.3 equals 0.9 chance of both of them dying. Okay, so have a go. That is all that there. If I can get my mouse to work again, we will have a look up here. Have a go at these questions. So your first lot is a heap of tables. Have a go at those ones that are marked. And then move on to the tree diagrams. These ones are all these ones where things are equally likely, and they've drawn them for you as well. Have a go at these questions. And then finally, 8F is our probability tree. You'll see that the probability for each one is different. This one here, 3 out of 7, there must be 4 on 7. And then it's given us it says description on our bags over here. So you merely have to work through there and put in your extra numbers. This one up the top here is clearly going to be out of 9, and I'm sure you can work out how many out of 9 you've got left.